still sick. My stepdad's okay, so I'm good. My coffee's here. You done with that?
Yeah.
No Valerie today? Or is there stuff back there? What's yours? Also yes. No Dana? Where? There's an L, an F, an R, a Q, an N, a T, a T, a U, an S, a G, a D, a Z. It's a T. Alright. Most people are finishing that up. Let's get some random humans to come up to the board. How's your drink of water? Good? The whole reflex? Did it mostly hydrogen and oxygen? Alright, row 1 is down there. Row 8 is down here. Let's get row 7. That's you two. You two are coming up. Susan, you can do it. I can. If I look at her page, it's going to be right. She can do this. It's fun. It's right. That one up there. You're fine. All right, then Arturo, you have to do it, but you have to hop. And then Eshburn, can do one of those. And then I need another row. Other row is row 8, so you two are coming up to the board as well. I don't make it up. I don't make it up.
Not 2 days in a row.
I like it.
I was kidding about the hopping. I'm actually not.
Can I just put it on the board over here?
No. It's very important that it's on the smart board. Good. Looking good on top, looking good on the right, looking good on the... Ooh, there's something wrong with the one on the bottom right. What's wrong with the one on the bottom right?
The middle. The D should be in the middle between G and M.
Why should the D be in the middle? What do you think? DJ? It's the vertex, right? And the vertex is where the two sides come together. Good. And then down here, I apologize, this was a little bit unclear as a picture. DJ is actually absolutely right. That T is currently naming the line because I didn't draw a point. So he's right. You could call that line T. If that T were actually a point, we'd want to call it like line TU or line TS. Okay? Line TU or line TS. And then angle TUS, where that angle actually forms a line. How many degrees is it if it forms a line? 180. We good on the warm-up?
Yep.
Okay. I'm going to give you a breakdown right now. It's after we do the IWSS bit with the distance formula in just a second, so I'll let you get up and turn those in a minute, not right now. So we're changing what we're focusing on to this guy right here. It's distance formula. We've already done this. It was 2 sections ago, I believe. It was section 1-3. So the one on the left is done for you. One on the right is the one I want you to do. And then we'll talk about it. So give yourself a good 2 minutes there. We'll work with that. 2 minutes, maybe a little more. You don't have a calculator. Raise your hand. You don't have a calculator. Where should you have a calculator? Bring to class. All right, you're gonna have to use somebody next to you for the last step. Okay. They're pretty close. The numbers are different between the two. The steps are the same. So you use the one on the left to help you with the one on the right.
No, asking what the numbers say.
Oh, what did they say? Pencil. And then the one you're doing is this one.
Don't you run on the back?
What's that?
Don't you run on the back?
If I have you right in the back, you won't be able to look at the solution at the same time. Okay. There's the other one. If more time would help you right now, raise your hand. More time would help you. Okay, a little bit more. Is that? There is one around. Good now? All right. So, actually, my copy number back to all of you. You got your square root down?
Yeah.
All right. So now we're going to talk through this solution right over here on this side. So I'm going to call and you're going to give me the next step and maybe how you need to do that. Okay? Three person. There is no person. Person four. How about what's next?
Square.
What's that?
Square.
Square root.
Wait, what?
So we're doing the first one down here. First step down.
Yeah.
Okay. What did you do?
4 minus 1. Okay, 4 minus 1.
You get 4 minus 1? Yeah. That thing, parentheses around it?
Yeah,
Square.
square.
Okay. Then what?
Check mark.
What is that check mark thing? What's that?
Square.
Square root. Square root is what that thing is, right? Okay. Then what?
And then -7 minus -5. Square. Parentheses.
-7 minus -5. Squared in parentheses. And then there's one thing that was in this step right here that I don't have over here. What's that?
Plus.
Yeah, the plus. Okay, is it clear where I got this from relative to that guy? Okay, another question that isn't about the next step just yet. This is just for clarity on how I knew. So there's the -4, and I put that first. Which of the 4 numbers over here, the -3, the -6, the 2, or the -1, of those 4, which is the number that my -4 is being treated like in this problem? What do you think? Hoffman? It's like the -3, right? Okay, so everywhere I see that -3 over here, at least for a while, it's going to be like this -4 right here. So it was first, so I put the -4 first. Yeah? Okay, so my next step, row 5, 1, 2, 3, 4, 5. Evens and odds. Even. Okay.
So for after that, you would -4, 1, -5.
Okay?
And plus do -5 minus.
Minus -7 minus -5?
-5 is -5. -7 minus 5, and then that would be just -2.
Yeah, this is a -2. Okay? And there's some stuff that I'm still missing on there. What am I still missing?
Get squared.
The squares? Okay. Let's do that. Now, giant freeze is the biggest place where we mess up all the time on this one. If you have a graphing calculator, hold it up in the air right now. Hold it up in the air. Hold it up in the air. Whew. Hold it higher. Okay, if there's nobody near you with a graphing calculator, like back there right now, shame on you, first of all. You're going to have to look at hers in just a second. If you have a graphing calculator, though, what I'd like you to do is type in -5 squared with no parentheses. So just -5 squared. Type that in. -5 squared. -5 squared. Vanessa, what'd you get?
Oh, -25.
-25. Okay. Now type in parentheses -5, close the parentheses, and then square, just like we see it here. Did you get 25? Those are different, right?
Yeah.
So the question then is, which one's got to be right? Okay, which one's got to be right? So if I multiply -5 squared, -5 squared is -5 times -5. A negative times a negative should be a what?
Positive.
A positive. So that the calculator, if I don't put the parentheses in, gets it wrong, so to speak, right? And the reason it does that is it treats the squaring like it's happening first, because it treats the negative like a -1 times 5, which isn't good for you. These two numbers that I get under here, like here I got 25 and 25, if either of them is negative, you did something wrong. Always. Because you're always squaring here and here. Okay? Can't get a negative number when you're squaring. Good? Okay, so then with that in mind, number 7, row 7, that's that row. Hello, Mr. Aschenbrenner, how you doing? Very excited? Okay, this 25 right here, I got from the -5 squared. That -5 right there. Where did I get that 25 from? The other -5 squared. Okay, so then here, what do you think I should do in my first step? No? Got an idea, Garland?
-5 squared is 25.
Okay. That's 25 from that -5 squared. You see how that is just like this one was? Okay. Then the other piece is what? BJ? 4? Do we agree with that? Do we agree with that? Okay. So then this is equal to the square root of 25 plus 4. What did I do with those two 25s? I added them? Yeah. Okay. So what does that mean I should do with the 25 and 4 next? Add them. When I do that, what do I get? The callus. Yeah. So there's that. And then the last thing I did was take the square root of 50 with my calculator, right? So what should I take here? Of what? Okay, and when I do that, what do I get?
5.4.
I'm making Caro. That's 5.4. Why is the equal sign squiggly? Do I just get excited because I'm done with the problem? No. Why is that a squiggly equal sign? I rounded, right? Until this spot, everything was absolutely exact. And then I was like, it's kind of 5.4. It's close to 5.4, right? Do I want to write all of those decimal places? No. In fact, I died doing that because it's an irrational number and it goes on forever. Okay? And I don't want to die writing one number for the rest of my life. Okay? Clear how we did that?
No.
Okay, that's distance formula today. If you think there's an outside chance that you maybe sometime and at some point could potentially make a mistake with a negative in there, raise your hand. Never? No mistakes with negatives? Okay, so we can do all the distance formula problems with all the negatives in the world?
No.
Oh, okay. So we're going to talk a little bit later today about how this thing, while yeah, it'll always work, we might want to avoid those negatives when it's possible to do so, and I'll show you some tricks so that we can avoid those negatives, all right?
Right there.
What's that?
Plus.
I could have just written 5 there.
No, the other one.
Here?
Top,
Yeah, I could have written +5 there. Sure. We'll do even more than that, where we don't even have to work with very many subtraction symbols at all. Okay? All right. So now, as promised, you can bring your warm-up over to there, and then take a seat again, and get out your yellow packets.
I was wrong. I was so lost at
Huh?
Check for one?
I'm checking the 1.5 highlighted ones at the end of the hour today. Which means really look convincingly like you're taking notes if you're scrambling.
No, I got it, Dom, don't worry.
All right. So this problem is the top of the back page of that set of notes. Okay, it's the top of the back page.
So basically the last page.
Yes. Back page, last page, they have some things in common, namely that they're the same. Okay? Anybody need more time to acquire their sheet? Jordan's getting set up. We're waiting for them. That's okay. You good? I'm very cross with you right now. Is it in your locker?
I don't know.
We'll fix it later. Okay. Anybody else? We're good? All right. So, we've got a word problem involving a rectangle, joy, right? And in this case, they tell us some things about the rectangle. Of course, they can't tell us how long the sides are. They have to give us a riddle about those sides, right? Kind of annoying. Okay? But they do tell us the area, right? 25 square meters. So I'm going to start by just drawing a little picture of that rectangle, just so I can kind of get some of the information that they're telling me out of Word icky form and into like how my brain can process it for me. All right, so rectangle. I know the area of this thing has to be 25 meters squared. Okay, it's got to be 25 meters squared. True? Which means that when I multiply x, if x is this side length, and y, if y is that side length, I better get what? 25? Yeah, because that's how you find the area of a rectangle, right? You multiply the length and the width. Is that true? Okay, so this on its own isn't good enough, right? I need more information than just what I have drawn. Not more than what they gave me, but more than what I have drawn. There's no way I could possibly solve for this. Think about it. If x was 12.5, then y would be 2, right? Because 2 times 12.5 would give me 25. If x was 25, what would y have to be? 1, right? So obviously there are multiple things that could potentially give me an area of 25 for a rectangle, right? That's not all the information I need. True? But they do give me a little bit more information. The other thing I know is that its length is what compared to its width? Its length is half the width? Okay, so this one actually looks more like it's the half side, right? So let's go with that one. So if this is y, then this one up here, instead of being x, how can I rewrite that as it relates to y? There's no number yet, right? But there. X minus y? Does that make sense for double? No. X times y? I've got y for a side length, right? I want this one to be twice as long as y. This is y. I want this to be twice as long as y. Let's plug in some numbers first, if I know it has to be twice as long. Okay? Let's say y was 10. What would x have to be if it's twice as long? 20. If this was 3, how long would this have to be? 6. If this was 2, how long would this have to be? 4, right? So what did I do every time with this number? I doubled it, right? I doubled it, or I multiplied it by... Is y squared 2 times y? Oh, what should I put on top? Not squared. Y squared would be 10 times 10, that'd be 100. Gracious, no. Okay. What did I do from 10 to get to 20? I multiplied by what? 2. What did I go from 3 to get to 6? Multiply by 2. What did I do from 2 to get to 4? What should I have to do to y to get to here? Multiply by 2. What's 2 times y? 2y. 2y. Okay? So this guy right up here, instead of being x, we'll call it 2y. Now I have more information. Okay, now I have more information. We'll get rid of these for you. Now instead of it being x times y gives me 25, now I have y times 2y gives me 25. True? Okay, so let's write that out. Y times 2y is equal to 25. Yeah? Yeah, I gotta do a little simplification now, right? Y times y is y what? Squared. So this is 2y squared is equal to 25. Now I gotta undo that multiplication by 2. How do I get rid of multiplying by 2? Divide by what? 2, okay. There it is. There it is. Y squared is then equal to 25 divided by 2 u decimal, but it's not that bad, right? 12 point what? Can I get a second on 12.5? Everybody agree with that? We get a second from BJ, but you don't have a calculator. Did you do it in your head? Okay, he's seconding, but he doesn't know why he's seconding. Somebody else with a calculator check that? 25 divided by 2? 12.5? Alright. Okay, so now I know that y squared is equal to 12.5. But I don't want y squared. I want to find the perimeter, which means I need y, right? I need y. How do I get y if I know what y squared is? What do I do to both sides of that thing? What's that, Amy? Square root. Take the square root of both of those. And I've got y is equal to some dreadful decimal. What's my dreadful decimal? 3.5-ish?
Yeah.
Is it exactly 3.5?
No.
So how would I say it's almost 3.5? Right now I'm lying to you. Wiggly lines? Oh, good call. That's a very technical term for it, the wiggly lines. Nearly equal to.
Close enough.
I like wiggly lines better personally. Very precise vocabulary is
easier
good
to
for most
remember.
things. These are very, very fun. Alright, but nearly equal to. Okay. Alright, so we have y. And the thing is, whenever I find y, I'm always like, yes, I've acquired the treasure chest, right? And then I forget to carry it back to the boat. Okay, so here's what I've got going on. Did I want to find y? Well, yeah, but what else did I need to find? What was it actually telling me to find? Not the width, the what? The perimeter. What is perimeter again? He really wants to go. Can I call on him? Go ahead. Around the outside, right? Okay. So this is 2y, this is y. If this thing is a rectangle, what's over here? Y. And what goes down here? So if we're counting up the number of y's going all the way around that thing, on the top I have 2. This is number 3, 4, 5, and how many do I have total? 6 y's, right? Okay, so my perimeter then is equal to 6y, which is equal to 6 times what number? Not times 1. Did I say y is equal to 1? No. Y is nearly equal to what? 3.5. And when I do that, I get 21. You agree? Yeah. Yep, sure. Ready to be more than yep, sure about that?
No.
What's 6 times 3? 18, right? And what's 6 cut in half? Yeah, so 18 plus 3 is 21. Hey, there you go. All right? Get over there. I'm blocking your view, sorry.
So is this like all of 6 too?
That's the entirety of that particular problem. No. Shaded problems for 1-6 are due tomorrow. Shaded problems for 1-5 are due today. Like 3 or 4. Got plenty of time now. We're doing just fine. Tape question. Okay, so there's this sort of annoying question that has multiple choices, and they don't actually have one that's exactly right. We have to find the one that's closest to being right. So I'm going to read this thing out loud to you. Whoa, if I can handle this podium. Okay, so Terry has 19 feet of tape. How many feet of tape does Terry have? 19 feet of tape. Can she use 20 feet of tape? Why not? Because he has 19. Good. Okay, so which of these shapes has a perimeter or circumference that would use most or all of the tape? So we want to use most or all of it. So it would be better to use 17 than 16, right? And it would be better to use 16 than 3. But 17 is still better than 20. Why is 17 better than 20? Because she only has 19 feet of tape. Very good. Okay. So our goal here is kind of Price is Right style, right? We're going up to 19, but not over, right? Don't want to go over. Does anybody understand the Price is Right reference?
Yeah.
Somebody, if you do, raise your hand. Wow, more than one. That's the first class.
I'm forced
Okay.
to watch it.
You're forced to watch it?
Only thing on TV at my great grandma's house.
What? Okay. You liked it a little, didn't you? No? Was it with Bob Barker or Drew Carey?
I always liked it when it turned into Family Feud.
Oh, okay. So Bob Barker, I don't think there's actually anybody on the entire planet older than Bob Barker at this
He's
point.
a Happy Gilmore.
All the time, Wheel of Fortune.
Wheel of Fortune? You like Wheel of Fortune or you don't?
Old enough to watch that.
Okay. How many feet of tape does Terry have? Oh, good. Okay. So the one word in there that's a little bit different than the other one is circumference, right? Circumference is just the perimeter of what kind of shape? A circle. Okay? So we have to find the perimeters of all 4 of these. It's not multiple choice where I get to find one and then be done. So the first thing we have to do is find the perimeter of a square with side length 5 feet. So this is letter A, a square with side length 5 feet. Area is equal to side squared. In this case, that S, the side length of the square, was how many feet? Side length of the square in letter A. How many feet? 5. So this is 5 squared is equal to, oh, excuse me, we're not doing area, are we? I'm lying to you right now. It's perimeter. My fault. Perimeter is equal to 4 times the number, or excuse me, times the side length, because I have 4 sides on my square. Each one of those is 5, so this is equal to 4 times 5, which is equal to 20. Can Terry use that? Why not? She has 19 feet of tape. Good. Okay. Letter B. Letter B, they tell me a circle, right? Got a circle with radius how many feet? 3 feet. So here's a circle. Radius is 3 feet. Diameter isn't from center to circle, though. What's the diameter? All the way across. Okay, so that's 3, and that would also be 3. So how far is it all the way across? 6. So this one is perimeter, or circumference in this case, is equal to 6 times what again? Pi. Somebody with the calculator, give me 6 pi. 6 pi. It is not good that this many people can't compute 6 pi in front of me right now. Yeah. 18.8. Is that one pretty good?
Yeah.
Yeah, because it didn't go over what number? 19. So this one's still possible. This one, definitely not. Right? Okay, we still need to check 2 more and see if they get closer. Right? And letter C, my perimeter is based on a right triangle with each leg 6 feet. That's 6, 6, and this guy right here is 6 square root of 2. If you've forgotten 45, 45, 90 triangles from algebra, you are not alone, but that's 6 square root of 2. Somebody with a calculator do square root of 2 and then multiply it by 6 for me. Square root of 2 first. Got square root of 2?
24. Square root of 2.
Square root of 2 is what?
4.
No, that's
No,
2 squared. I want square root of 2.
Oh, wait, I got it.
Just got a 1.4 here. Is that what you get?
I don't even know. I screwed up. I don't even know. Which
Giant blue button right here. Hit that
Yes,
guy.
second.
Second. And then hit the x squared key.
Yeah.
And then hit 2. All right, that's it. 1.4. Did you get 1.4?
Yeah.
All right. So that's 1.4, and then multiply that thing by 6 for me. What do you get?
8.4.
8.4 something. This is 6, and this is 6. 6 plus 6 is, plus 8 is 20, plus 0.4 is 20.4. Is this one okay?
No.
Oh. Last one.
You sounded so disappointed.
Rectangle with length 8 feet and width 3. This is the easiest one for last. Letter D. 8, 3. What's down here? 8, and here? 3. 3, 6, 14, 22. No way. Okay, all three of the other ones went what? Over. So 18.8 wins by default. All right. One more example. Okay. One more. The one on the bottom right, the one that has DOG, we're going to get rid of that one. So the bottom right one you can get rid of. You can use the space that's under that to write if you can run out of room. So the one that says find the perimeter and area of triangle dog, get rid of that thing. We're not doing it. Okay? We are going to do the other one now. And that's this guy right here. And we need to zoom in a little bit to make this happen. Alright. So the first thing we got to do is recognize that they're asking me for two things. Perimeter and area. Perimeter is probably the trickier part right now because we have to find the side lengths. And the way we're going to do that is with the distance formula. Right? Okay. So -1, 4 is letter A. So I'm going to plot that. -1, +4. Which one was that? A, B, or C? A. And then I've got B at 0, -1. That's right there. And I should use a different color. This is a bad choice. Nope. And the last one was at 6, -1. And this one here was B, and this one here is C. Now, remember earlier when I asked if it looked like the distance formula would be a good idea to do lots of times, and nobody chimed in because we don't like chiming in general, but then I was like, so I should throw lots of negatives on there, and then we were like, no, let's not do that. So the distance formula is something that always works. We'll do it if we have to, but we're going to avoid it if we can. Okay? And by avoid it if we can, I mean we're going to skip some of the steps where we have to do a lot of reasoning with negatives because they're not necessary anyway. When I do a distance formula problem, I'm ignoring lots of negatives because I know that I can and it's not going to give me a problem. And I'll show you how to do this exactly the way that I do it. Okay? Now, on this figure, I only have to use the distance formula twice. One time I don't have to. Here's how I know if I have to use the distance formula. If the line segment is at an angle with respect to the coordinate plane, I got to use the distance formula because I can't just count blocks. If it actually lies along a line, I can just count blocks to get my distance. Does that idea make sense? Okay, so of these three sides, AC, BC, and AB, why is BC the one that I don't need to do distance formula for? Huffman? Well, they're all straight. Yeah, it's not slanted or tilted in the plane, right? Okay, so how long is that one, BC? 6? Okay, you want to know I did that? 1, 2, 3, 4, 5, 6, done. Good? Okay, so that was one of the three that we needed. Now, another one that I need is this AB business, so let's write that down, AB. Now, if we wanted to, we could take the coordinates for A and the coordinates for B and do the fully fledged distance formula like we did in the warm-up, right? You ready to do something a little bit more efficient than that? Okay. AB is equal to, well, we still need that square root. That's still going to be there. Okay? But what we are actually doing is figuring out how far left and right we traveled and how far up, down we traveled and squaring those values. So, to go left, right from B to where A was, I have to get from here over to here. How far is that? 1? 1 squared. Okay, so we just handled the left, right. What else do I have to handle? The up, down. So to get from down here where B was up to where A is, how far is that? It's not 10. 5? Do we agree with 5?
Yes.
How could you check? Count blocks, right? 1, 2, 3, 4, 5. Is 5 good? Okay, so that's 1 squared plus how many squared? 5 squared. Now, let's imagine I had actually used the distance formula, right? Let's imagine I had actually used the distance formula and I was using A and B. That would be 4 minus -1. Is 4 minus -1 5? See what I did? Okay, but we're avoiding those negatives and trying not to get lost in the algebra of the thing. Okay, so then this is equal to the square root of 1 plus 25, which is equal to the square root of 26, which is nearly equal to what? square root. What button do you hit first? Uh-huh. 26. 5.1? Yeah? Alright, so that one's about 5.1. And I can just put it right on my figure. 5.1. Done. The other one I'm going to do the same way. This one is AC. AC is equal to the square root. How far did I go left, right? 1, 2, how far? 6? Bigger than 6? I don't think it's 6. 7? 1, 2, 3, 4, 5, 6, 7. 7. Plus. And then how far up, down? Well, same amount of up, down as we went before, so this one is 5. That's equal to, let's scroll down a little bit, the square root of 49 plus 25. Which is the square root of 74. I'm very confident that you can do this now. So this guy right here is 8.6. You good on that? All right, well, if I add those three things up, perimeter is equal to 5.1 plus 6 is 11.1, plus 8.6 is 19.7 units. We'll have to cover area tomorrow. Please show me your highlighted problems, bring them over to me, and I'll write you down that I saw it. And then you will be set. If you didn't do it, don't bring it up.